Hello, hope you're enjoying science expeditions so far. Welcome to the Wisconsin Energy Institute's microgrid mapping activity. Before we get started, I'd just like to say that the only materials you'll need for this activity are a piece of paper and a writing utensil. So with that said, let's get started. My name is Lucas, and I'm a student education and outreach programming assistant for the Wisconsin Energy Institute, which is a cross-disciplinary center for energy research on the UW-Madison campus. Here, over 260 researchers study things from microgrids to biofuels to renewable energy systems. And we also provide several undergraduate and graduate certificate programs for those interested in studying energy. So if you're thinking about college and you're interested in energy, that could be something cool for you to check out. And we're located just north of Camp Randall Stadium on the western end of campus. We want to acknowledge that the land we reside on is the ancestral home of the Ho-Chunk Nation and 11 other First Nations groups residing in present-day Wisconsin. We want to acknowledge their inherent sovereignty and also recognize that these groups are doing some of the most important and leading work in transitioning to clean energy systems today. So we'll kick things off with a little drawing activity exploring where our energy comes from, how it gets transported to our homes, and the changes it goes through on its way to our homes. So I'm going to ask you to draw an outlet on your piece of paper and try and picture what object the electricity travels through before it reaches that outlet, and draw that object with an arrow pointing from it to the outlet. And then you'll repeat this process until you've gone as far back as you can go, trying to envision all the steps of the energy transmission process. And don't worry if you don't know all of these steps or if you don't know any of these steps. That's what we're here to learn, right? So you could think about the structures you can see while traveling in your car as you draw your energy pathway, or you might be able to look out your window right now and see something that can fit into this drawing. And I've gotten you guys started a bit here. So here's my outlet on the right, and then directly connected to that is a service panel. So you guys have probably seen this in the basements of your homes, and here electricity is received from outside and then distributed to all the places in your house that it needs to go. This is also called a fuse box or a circuit breaker panel, and this is where you go if the power goes out and need to reset the circuits. So with that all said, you could pause the video here and take as much time as you need to make your drawing. Awesome. So now that you guys have had time to think about all the steps of the energy transmission process and draw them on a piece of paper, I'm going to show you my drawing, which is an accurate drawing of how this energy pathway works in Wisconsin. Don't get overwhelmed when you see it. We'll go from the outlet all the way back one step at a time. So here I have my outlet connected to the service panel, and then that's connected to a meter. And you guys have probably seen meters on the outside of your homes, and that just basically measures the amount of electricity that comes into your house. Attached to the meter is a transformer. You guys have probably seen this all over your neighborhoods. A transformer is just a big green box that acts as a sort of faucet for electricity. So when you go wash your hands, you don't just bang on a random pipe and let the water spurt out and hope it's the right amount, right? You need a faucet to control the flow of the water so you don't get too much and you don't get too little. Transformer does the exact same thing. It receives lots of energy and then it puts out a constant lower amount of electricity so that it doesn't get dangerous and so that we have exactly the right amount we need to use. These transformers receive electricity via distribution lines, and these are the power lines you guys have seen all over your neighborhoods. They basically transport electricity from one place to another. Specifically, they transport electricity from substations, which is just a kind of a fancy word for a larger transformer. It has the exact same function, except it's way bigger. And we have about 9 of these in the Madison area. Connected to the substation are larger transmission lines that are the same thing as distribution lines, except they're bigger and they're made of this metal lattice structure. And you can find them on the sides of bigger roads, such as highways. These transmission lines carry electricity from a transformer, just a bigger substation, and that transformer is attached to a coal power plant. Coal is our primary source of electricity here in Wisconsin, and at the power plant we burn coal to produce steam. That steam rises and spins a turbine. That turbine is connected to a generator that converts the mechanical energy from the spinning turbine into the electricity that we use. So this is where electricity is produced, but we're going to go even further back in this process and explore where this coal comes from. So coal arrives in Wisconsin via a coal train. We don't have much coal here in Wisconsin, so we have to get it from another state. And that state is usually Wyoming. That's our #1 supplier of coal. And here at Wyoming, there are lots of coal mines where these really cool big trucks carry coal from the mine to the train. So now here we just have our raw coal sitting in the ground waiting for us to extract it and turn it into electricity. This is one of the coolest parts of this presentation, I think, because when you explore where coal comes from, you'll find it comes from prehistoric plants that have been compressed and exposed to thousands and thousands of years of intense heat and pressure. So all the organic materials in those plants condenses into coal. So now there's one step of this process that I haven't shown you guys, and I'd like you to just think about what that might be. Here, the energy is locked in plants, and those plants will eventually become coal. So where do plants get their energy? From the sun, right? Through photosynthesis. So that's a really cool concept, and it's a big takeaway from this presentation. All the electricity that we use in our home ultimately comes from the sun. And that'd be true no matter where we live, no matter what sources we get our electricity from. Solar power comes directly from sunlight. The wind turbines that we sometimes use in Wisconsin rely on wind current patterns that are generated by the sun. Even hydropower and biomass, those all come from the energy that's locked in sunlight. So now that we've explored where our electricity comes from here in Wisconsin, I'd like to introduce another way of thinking about power grids. That's called a microgrid. So microgrids are small local power grids existing separately from the larger power supply. They use advanced technology and software to combine and direct power from many different sources. So this image on the bottom does a really good job of describing what a microgrid is. So this town is supplied by electricity from, say, a coal power plant on the left here. And these 5 buildings are connected to a microgrid that gets electricity from some other sources. So let's say that this building has a diesel generator that produces electricity, and this building has some solar panels on its roof that produce electricity as well. And microgrids have a central system where those different sources of power will be combined and then redistributed to these 5 buildings as it sees fit. So thinking about microgrids, what kind of places do you guys think would benefit the most from them? Here's a good opportunity to pause the video and talk amongst yourselves, or just think to yourself, what kind of places would be most in need of a microgrid system as opposed to a traditional power grid? To illustrate the answer to this question, I've just selected some really cool examples of microgrids around the world to talk about. So here in Corteau, Haiti, is this town, a really small town that previously didn't really have access to electricity. They were too far away from any larger power grid. They had a couple diesel generators that supplied electricity to really important buildings like hospitals and schools, but most homes didn't have electricity. And this town recently installed a solar panel array on this little farmland, this little piece of farmland here. And that solar panel array supplies over 2,100 homes with electricity. And these homes had never experienced electricity before. So this is a really good example of how microgrids can bring cheap electricity to remote areas that didn't have it in the first place. Here on the right is Alcatraz Island. You guys have probably heard of the famous prison that was located there. And that prison shut down in 1963 because it was too expensive to run. And a big reason for that was because they were isolated from any sort of power grid. So they had to spend lots and lots of money shipping thousands and thousands of barrels of diesel oil over to this island every week. And that was just not sustainable. So the prison shut down, and now it's a tourist attraction that you can go visit on a vacation. And recently they installed a solar panel microgrid on the roof of the main prison complex. And these solar panels supply the island with 50% of the electricity that it needs. So that drastically reduces energy costs and makes it much easier to run and cheaper to visit if you're a tourist. In addition to bringing power to places that don't have it, microgrids can also supply extra power in larger cities where they might be most needed. So here on the left is Kaiser Richmond Medical Center in California, and this is a hospital that recently constructed a solar panel powered microgrid on the roof of their parking garages. These solar panels provide electricity to the hospital in case the main power grid experiences a blackout. I'm sure you guys can imagine all the awful things that could happen at a hospital if the power goes out. And these solar panels provide a really good fail-safe against that. So the hospital will always have electricity no matter what. On the right here is Princeton University in New Jersey. And recently, Hurricane Sandy tore through the state and knocked out most of the power. But Princeton University was able to continue running because they had a solar-powered microgrid that supplied the whole university with power throughout the storm. So these are two examples of microgrids supplying extra power in cities where you wouldn't expect extra power to be needed, but blackouts always provide a risk. So what are the benefits of microgrids? Just to recap, they bring electricity to remote places that can't connect to a larger grid. They store electricity that can be used during a blackout. This is called grid resilience, basically having multiple sources of electricity that you can rely on. They make electricity cheaper. They make it easier for us to use renewable energy. It's much easier to install solar panels on your roof or a wind turbine in your farmland than it is to burn coal or construct some sort of power plant in your backyard, right? So microgrids just inherently lend themselves to renewable energy. Finally, they allow for energy autonomy. What does this mean exactly? It means that the people producing the electricity in a microgrid are also the same people using it. So they get to produce the energy, control how much is produced, and control where it goes, instead of relying on some faraway power plant for all their electricity. So just to wrap things up here, I'd like you to look back at the energy pathway you drew. How do you think it would look different if we got all our electricity from a microgrid running on solar power? You could even redraw your energy pathway to model a microgrid instead of a traditional power grid like we have in Wisconsin. What kind of changes would you make? Awesome. So that concludes our microgrid mapping activity. Thank you so much for participating today. If you'd like to get in touch with us, you could contact outreach@wisc.edu. And if you'd like to learn more about the Wisconsin Energy Institute, you could go to energy.wisc.edu. Again, thank you for your participation and enjoy the rest of Science Expeditions.